So we say 1 AMU is 1/12 of carbon's atomic mass. Okay. Why 1/12? Because you will know that the mass of electron is how much? Write down mass of electron 9.1 into 10 is 31. 9.1 into 10 is power minus 31. This is the mass of one electron. Okay? 10 is power minus 31 kg. Okay? Mass of proton is roughly equal to mass of neutron, which is 1.67 into 10 is power minus 27. Now tell me how many times one neutron or proton is heavier than electron? Around 2000. So when you talk about the mass of an atom, you ignore the electron's mass. Just consider mass of proton and mass of neutron. Okay, so that is why you know what is the mass number? What is atomic number? Number of protons. What is mass number? Not necessarily plus. Not plus number of protons. Hello. In class. Okay. So mass number is atomic. Different. ये चालू करते हैं मुझसे चार भी नहीं करते भूल ही गए आज मैं अपना नाश्ता करके निकला खाने को ये मिल रहा नहीं ठीक है तुषार अरे काका तो बोलो अरे ठीक है क्या कर सकते हैं तो डाटा करके निकलेगी ठीक है so what I was saying was mass number is mass of proton plus mass of neutron. We don't consider electron at all. Why? Because when it comes to mass, electron is irrelevant. Okay? So C12 has proton 6 and neutron 6. Okay? That is why you divide by.
Should I start, guys? There are only 4 people. I thought there would be all 12 people. That is why I started class in YouTube.
Is taken as 1 AMU. Okay.
Well, let me wait for a few minutes. Who has already joined is Sanjana, Ritu, Tanay, Shraddha, Varsha.
Atomic mass unit is 12.
Anchita has also joined.
Hydrogen atom has only one proton inside. So hydrogen's mass will be approximately 1 AMU. Right? Similarly, chlorine, similarly sodium, like that. Okay. So, but then it will be close to it. It will not be exactly to that. It could be that hydrogen atom will be 0.99997 AMU. So because even though the neutron and proton have similar mass, but they are slightly different. So you haven't had something. You never heard of Poland. Unfortunately, you I taught class 12.
Dhruti has also joined.
Only iron compound is there. So what is an iron?
Okay, so I'm starting with circles. Anyone please let me know. As far as I remember, I have done circles a little bit in the class. So do you want me to start from the beginning, or you want me to do it from where I have left? And second thing, how much more is left out? So just go through your syllabus and just check what is left out, because your first exam is on 18th February. So I would like to finish it by from beginning. Okay, just let me know which all topics are left out. Okay, I'm starting from beginning. Don't worry, I'm starting from beginning.
So like that, you should be knowing the charges of few of the elements. For example, here you can see that sodium is Na plus.
Dhruti, only circles is left out.
This is silver Ag plus Cu. Cu can be Cu plus Cu2 plus also. Okay. So Mg2 plus Cu2 plus Zinc2 plus. Okay. So Al3 plus Fe can also be 2 plus and P minus. Okay. If you remember this, any
topic that. Okay, fine, good.
Okay. If a compound is getting formed.
Which topic, Sanjana, in Maths 1? I'll finish it off. Probability. Okay, I'll finish it off. Probability. What I want you is that. Sanjana, what is Ig?
Na is Na plus. In order to become neutral.
Okay, fine. So let's do one thing. Statistics and probability. Okay, let's do one thing. When I meet you next week, I'll finish off circles. And then I'll take an extra class perhaps next week on Sunday or something. So that day I'll take probability and statistics.
If take suppose 2 CL, then it becomes NaCl2 minus 1. Because it has to be neutral. Okay? Because in nature, all things are neutral.
What I want now is all of you get your R.S. Agrawal with you, because I will be directly referring to the theorems which I am going to take.
I have like zillions and zillions of electrons inside my body. Suppose this pen, I'll just give you an example of what kind of force can be there. First of all, this table, which is stable, has so many number of electrons. If I remove 1% of electrons in this table, okay, and 1% of electrons I remove from my body. Okay.
Suppose this is my circle. So this is known as center, and center is denoted by word letter O. Any point on the circumference. What is circumference? So the perimeter of the circle is known as circumference. So complete perimeter, this circular arrangement is known as your circumference. Any point, distance between any point on the circumference and the center is known as radius r, and it is denoted by a small letter r. What is a chord? Chord is distance between any 2 points on the circumference. So if you draw a line between any 2 points on the circumference, that would be chord of the circle. So what is the biggest chord of the circle? Biggest chord of the circle would be diameter, because it will be passing through the center and joining the line on the other side. So biggest chord is diameter. Now diameter is 2 times of radius. So what is a secant? So secant is extension of a chord. So any line which crosses or which intersects 2 points on a circle is known as secant of the circle. So it's an extension of the chord. It's just that I have extended this chord. Suppose the chord is AB and I extend it to CD, and this secant CD intersect the circumference at 2 different points A and B. So CD becomes secant.
if aluminum will also react with oxygen, but it should be.
Now, what is a tangent? So tangent is something like any line which touches the circumference of the circle at only one point. So a line that intersects the circle exactly at one point is known as something like this, is known as tangent. So this line P and this is Q is known as PQ is known as tangent of the circle. I want all of you to be with your R.S. Agarwal because I'll be taking theorems of R.S. Agarwal directly.
So like that, you have to actually find out the least common.
Now next thing is
the reactive components.
Interior of the circle. So any region which is inside the circles. So this region will be known as interior of the circle. And whatever is outside this circle is known as exterior of the circle. So the way to define interior of the circle is any point. Suppose you take the center O and you take point P. If distance between any point P and center O is less than R, that would be interior of the circle. If you take any point Q such that distance OQ is greater than R, that would be exterior of the circle. So that's how it is. Now, what is circumcentric circles? Circumcentric circles are those circles which have same center and different radius. So try to understand it here. This is the point, this is my circumcenter, this, and I have different radiuses. So this is R1 and this is R2. So these two circles, suppose this is circle C1 and C2. So I'm writing circle C1 which has radius R1 and circle C2 which has radius R2 would be known as circumcenters, because the circumcenter is by property those circles which have different radiuses but same center. So wherever I am talking about circumcenter, you should be having these concepts in mind. Next topic is arc of a circle. So arc of a circle is a portion of circumference. So a portion of circumference is known as arc of the circle. So suppose this is A, this is B, and let's take this point as P. So this APB, which is a part of complete circumference, is known as arc of the circle. And arc of the circle is denoted by this arc sign over the alphabets. So this kind of sign above any particular alphabet or something like that would be known as arc of the circle. Now any arc of the circle would be making some angle with the center. So see this arc AB, if I ignore P for the some time and I write arc AB is making angle AOB at the center. And suppose this I assume to be theta degrees. So this theta is known as, or angle AOB is known as degree measure of an arc.
And amount of reaction will be equal to amount of light formula. So if I'm exposing it to suppose this board.
So wherever I write like this AB and I write angle AOB is equal to theta, you should understand that AB is an arc where this arc AB is making angle theta on the center, and if I use the terminology degree measure of an arc, you should understand that arc is making that much angle on the center. Now what do you mean by congruent arc? So congruent arc means those arcs which subtend the same angle on the center. So suppose I have an arc here in the same circle I am drawing, and this is PQ, and This PQ is also subtending angle theta on the center. So arc AB would be congruent to arc PQ. There, sorry, arc PQ. So I write P here. Arc PQ. So as soon as I use word congruent with the arc, you should understand there is only one condition for arcs to be congruent. There has to be same angle subtended by those arcs on the center. So that becomes congruent arc. Now semicircle, we all know half of the circle is known as semicircle, or when the arc subtends 180 degree on the center, that arc is semicircle. So you see here, if I draw this circle for you, and if this is the arc I am considering, so this arc AB, if I take arc AB, I mean this complete thing, and if I look at this angle subtended on the center, this would be 180 degrees. So arc AOB angle is 180 degrees. So arc AB would be known as semicircle. Okay, now what is minor arc and major arc? So try to understand. Minor arc means angle of the arc subtended or degree of arc is less than 180 degree. And if degree of arc is 180 degrees, so let me write major arc here. So if degree of arc is,
so formula mass unit or formula unit mass is simply just add
greater than 180 degree, that would be known as major arc. So let me draw a circle over here. This kind of, suppose this is the arc from here to here, and this is AB. So and this is the point. So this theta is less than 180 degree. This would be minor arc. And you look at the other side of it. This side of AB is subtending this angle which is more than 180 degree. So this is greater than 180 degree. So that would be major arc. Wherever you are not understanding, please raise doubt. Please don't keep on listening things.
So the mass unit of the compound is.
So now let me move to, I'll come to cyclic coordinator later. Now let me move to theorem. So first theorem is theorem 1 is congruent circles. And what do I mean by congruent circles? So if you go to R.S. Agarwal, I'm just reading it for you. The congruent circle means if two circles have same radius,
then comes the mole constant.
Then those circles would be known as,
we always are in a mode of what will happen, what is the property of one
congruent circles.
We never discuss about how atoms will combine to create.
So here it is. There is a circle here. This is I'm assuming it to be O. This is circle C1 and radius is R. And suppose I'm assuming this to be S, center to be S, and this is circle C2, and such that this radius is also R. So circle C1 is congruent with circle C2. Now try to understand. I told that arcs are also congruent, and I told that two arcs are congruent when the angle theta is same for those arcs. You need to understand difference between two different arcs and two different circles. For two different arcs, I am assuming arcs to be in the same circle. For two different circles, as the language itself suggests I am drawing two different circles. So don't get confused that how radius is becoming equal and how theta is becoming equal. If theta is equal for arcs, it is between the same circle. Congruent circle means I have two different circles altogether. So
basically, if you understand the numbers, both concept is nothing. Okay.
This is how it is. Now let me move to
nothing but it is a number.
Second theorem.
So
all of you please write till now whatever I have explained, you have understood everything. I don't know what you are doing at home. All of you please respond.
Similarly, number will not be convenient when you talk about the collective.
Have you understood everything?
Number. Okay. For example, I want to see.
Okay, Dhruti has said yes. Others.
And other test you have taken 200 ml or something. So I want to know when I mix this 200 and 100 ml.
Okay, Ritu, Sanjana, Shraddha, Tanay, Anchita. Okay, good enough. Now let me go to theorem 2. And theorem 2 tells me that
if somebody tells you that okay, in this condition, if you take, say, if I tell you exactly
so
that,
now the theorems that I'll be talking would be about the chords and its properties.
Because I know exactly that two molecules of hydrogen combining with one molecule of oxygen give two molecules of H2O. So if I know that in 100 ml of water exactly how many number of water molecules are there, that's a very useful information.
First theorem is, which is theorem 2, so I'm writing T2. Equal chord.
It's purely a game of numbers. Right? So Avogadro was a great scientist who could visualize or could come up with something like Avogadro
tend
who has told us concept of
equal angle.
Okay. He has given this magical number one mole
at the center.
One mole is 6.02.
So suppose this is chord AB and suppose this is chord CD. So suppose this is angle theta1 and this is angle theta2. I have to prove that I tell you that AB is equal to CD. This has been given. And I have to prove that theta1 is equal to theta2. Now what I do is that, try to understand, I take two triangles, triangle AOB and triangle COD. I know OA is equal to OD. Why? Because they are radius. OB is equal to OC. Why? Because they are radius. And AB is equal to CD, which has been given to me. It means that I have side congruency. Now, by CPCT, corresponding paths of congruent triangles are equal. Angle opposite to equal side. So opposite to AB, theta1 is there. So I am writing here opposite to AB. And opposite to CD, theta2 is there. So I am writing here CD. So theta1 would be theta2 by CPCT. So that's how you have to prove it. Now what you have to do, I am writing, Anirudh, why are you late? Are you just going to ask that Anirudh is not there? I'm always looking for you. You can't bunk my classes.
0.23. It will have units of.
And who is not there? Diksha is not there. Shreya is not there. Aditi is not there. If they are there, just give your names because I have not Theorem 3, you have to prove it that if angles subtended by two chords at the center of the circle is same, then the chords would be equal. Just prove it. I'm giving you 1 minute of time. It should not take more than 1 minute.
And pressure is taking atmosphere. That is the unit of looking at the unit of R, you can find out whether you should take pressure in atmosphere or something. You know right what you want. But then the problem is this particular thing is valid only for this. This relation you can't use for anything else other than this. Okay? So it is important for us to understand beyond the gas equation as well, because at times you are dealing with reaction in a liquid. Okay. So write down a concept of molecular mass. So molecular mass
done.
Which standard sheet is yes, sir. Right now, we went little early because the pressure from the parent themselves. You know why? Because all the other coaching institutes they start giving calls to the parent.
Okay, great. All of you have done it. I'm very happy. So I will just, for the sake of confirmation, I'll do it. Suppose this is AB and this is CD and this is center O.
Month of November we came, right? Month of November or October. And the session is going to start in after it. So like it is like 6 months before.
Theta 1 is equal to theta 2 has been given, and I have to prove that AB is equal to CD. Now what I need is, I will say that I take triangle AOB, suppose this is O, and triangle COD. So I'll say that OA is equal to OD because it is radius, and OB is equal to OC because it is radius, and angle AOB is equal to angle COD. It has been given. So it is side angle side angle side congruency, and again by CPCT, sides opposite to equal angles would be equal. So AB, which is opposite to theta 2, would be equal to CD opposite to theta 1. So this is what you had to do. All of you did it. So wonderful. Now let me go to theorem 4. So theorem 4 is, if
if you take my example, my 10th old marks, I scored just 17%. So that point in time used to be, you used to get marks. You don't used to get grades. So I scored 71% and
congruent. If two arcs of a circle are congruent, then corresponding chords are.
So if you talk too much about how being
Sorry, I have written parts. It is chords.
So you cannot judge a student till the student comes to
Are equal. Now, guys, try to understand its extension of the its extension of the third theorem that we just proved. So what happens is, if two arcs are equal, first of all, try to understand the relationship between chord and arc. So suppose I take this chord arc AB. So arc AB is this portion of the circle. Is it okay? A part of circumference. Now, if I draw a line from here, so arc AB is related to this chord AB, because both arc AB and chord AB would be subtending same angle theta on the center. So if somebody is telling you that arc AB is subtending an angle theta on the center, oh, you should know that he's also talking about the corresponding chord. So chord of an arc would be subtending same angle on the center. So he is saying that arc of the two circles are congruent. It means that he's saying that suppose this is arc AB and arc PQ, and it is subtending same angle theta over here. He is also telling me that chord AB and chord PQ is subtending same angle on the theta here, and if I assume that AB and PQ are subtending same angle theta on the center, this theorem 4 turns out to be theorem 3. Now, how do you prove it? You have to prove the same thing, that AB is. You have to prove the same thing, that SAS congruency would be here. So I write OA is equal to OQ, OB is equal to OP, and theta is equal to theta AOB. So by SAS congruency, AB comes out to be equal to PQ. I just wanted to explain one thing, that every arc has a corresponding chord, which arc is the length on the circle, chord is a straight line between the 2 points, so that becomes corresponding chord. And if arc is making angle theta, the chord will also make the same angle. This thing you need to understand, and this theorem was an extension of theorem 3. So I hope you all understood it.
Class 10 would start in March. Let me tell you the exact date.
Okay, now let me go to theorem 5. Theorem 5 says that it's the same thing. I'm not doing it. You have to make two chords equal. Okay, just do it. You just go and see this theorem in R.S. Agarwal. Just go through it. Don't solve it. Just go through it. Theorem 5 says that if it's not theorem 5 in your book, just search for if two chords of a circle are equal.
That will be 9 a.m. to 1 p.m. Mixed of classroom.
Then there are corresponding arcs. And when I talk about arcs here, I'm talking about three. I have taught you three kinds of arcs: minor, major, and semicircular. So I'm talking about all three of them are congruent. So you have to do this.
Yeah.
Okay. Just try to solve it. Take 2 minutes.
Other details will send you. You might have received the filling of the form. On WhatsApp only, there will be a link. Please fill that form. Yeah. You know, right, what is so special about moles, right? So you'll have a relation with moles, pressure, volume, and temperature of gases. Okay? So you'll exactly know how many moles will be there at a particular pressure, volume, and temperature. And once you know how many moles are there, one mole will have that many atoms, 6 into 10 to 23. So you exactly know how many atoms are there. Okay? So that is why there is a significance of mole. You know the number. Okay? But when it comes to the aqueous state, you can't use this. Okay? Because this is a gas law. This is gas law. You value with gas. Okay? When it comes to aqueous state,
are you done with? It will take some time. So
we'll never use this formula, but we use concept of mole. What is the concept of mole? That one mole will have that many of substance. If I say 1 mole of phone, that will have how many phones? 6 to 10 to 23 phones. 1 mole of compound, that many compound. 1 mole of anything means that many number of that substance. Understood? So now mole is so widely used that we define the molecular mass also with respect to mole. What should be the molecular mass? The mass of 1 mole of that molecule. Understood? Right now, molecular mass is the mass of 1 mole of the molecule.
Just try to understand properly how it is doing for major, minor, and semicircular arc. There is nothing different in that. Just
okay. Usually we represent mass in grams. The molecular mass we represent in terms of grams. Okay. Now similarly, the atomic mass will also be the mass of 1 mole of that atom. Okay. For example, atomic mass of
done. Okay, 1 minute. Take 1 minute. No issues.
1 gram. Okay. And atomic mass unit of hydrogen is 1 kmu and 1 gram. Okay. And similarly, the molecular mass will be given. Okay, for oxygen it is 16, the atomic mass, 16 gram. 16 gram will be the mass of 1 mole of oxygen atom. 32 gram will be the mass of 1 mole of oxygen molecule. And 4 grams will be the mass of 1 gram of helium gas. Alright? So, this is the mole concept in your syllabus, but mole concept is very involved concept. When you come to class 11, you see that. Yeah.
Okay, are you done?
No, sir. If during summer holidays, it will night. If school is there, then the school after school will take for 2 hours. If school is not there during summer time, then I need to. Can you forward that to me, sir? So now tell me, look at that reaction. 2H2 plus O2 gives 2H2. Okay, now tell me, how many moles of hydrogen?
Okay, fine.
React with
Anchita, are you done?
React with 1 mole of oxygen to create.
If you are not understanding anyone, if you are not understanding, please let me know. I will solve it. I have no issue solving it.
If two number of hydrogen reacts with 1 number of oxygen to create 2 number of H2O, similarly 2 moles react with 1 mole to create 2 moles. It is treated just like a number. It's a huge number. Now, can you find out right now number of moles? Find out number of moles in 52 grams of helium. Molecular mass is 4 grams.
Okay, I am solving it then. But wait for a moment. So, try to understand. I'm first of all taking it for.
Yes.
I've been given that if 2 chords of a circle are equal, then the corresponding arcs are congruent. So chords, first of all, I'm taking diameter, and suppose this is center O.
0.04.
So this is A, this is B, this is C, this is D. And I have been given that AB is equal to CD. I have to prove that arc AB is equal to arc CD. So what I will do is that I will simply write that AB and CD are diameters. So if AB and CD are diameters, arc AB and arc CD are semicircles. Now if they are semicircles, it means that
this many number of X elements.
It means that semicircle chords would always be congruent. If they are semicircle, they are making 180-degree angle. It means that arcs are congruent. If arcs are congruent and chords are equal, then arcs will also be equal. So I can write over here as arc is congruent, and if AB is equal to CD, chords are equal, then arc AB would also be equal to arc CD. This is it. Now I will go when these becomes minor arcs, so I'm removing it. Let me do it for minor arc. Now, if I make it for minor arc, suppose this is my circle and this is AB, and I'm sorry.
Always follow using this.
This is AB and this is CD, and it has been given that AB is equal to CD. I am taking minor arc. Suppose this is P and this is Q. So I am taking minor arc APB and minor arc CQD. This is center O. So what has been given to me is the same thing actually. I just draw a line from here. I will say that OA is equal to OB. OB is equal to OC and angle, and sorry, AB is equal to CD. So this is side congruency. If this is side congruency, it means that this angle by CPCT, angle AOB is equal to angle COD. It means that corresponding chords of the arc are making same angle, and if AB is equal to CD, then corresponding chords APB would be equal to corresponding chords CQD. Fine. Similarly, you can do it for major arc. So I'm not wasting time over there. Now let me move to another theorem. The class may extend. I don't know. Maybe it can be of 3 hours also. So don't worry about it. Leave all your plans and sit there and enjoy the class. Theorem 6. The perpendicular from the center of a circle to chords, from center to the chord bisects the chord.
0.1 mole of carbon.
So nothing you have to do. You draw a chord here, and this is O, this is A, and this is B. You draw a perpendicular from here. What I need to do is that I need to draw these 2 lines, and then I'll have 2 triangles. So I take triangle, suppose this point is P. So I take triangle O. I take triangle OPA and triangle OPB. So in this 2 triangle, OP is equal to OP, side is same, and OA is equal to OB, their radius, and angle APO is equal to angle VPO because it is perpendicular. So this is 90 degrees. So what kind of congruency I have? I have RHS congruency. So if I have RHS congruency, so it means that
there are some assumptions made for a gas to be an ideal. First one is
it means that
the size of the atom,
this angle
is negligible
and this angle are equal. And how will you say that
you could solve
these AP is equal to PB you have to prove? So how will you say that AP is equal to PB? So this is 90 degree and suppose this is theta. So this will be 90 minus theta in both of them. So angle of side opposite to same angle would be same. So you see here AP comes out to be PB because angle at both the places is same, 90 minus theta and 90 minus theta. You should also know that it can be the same theorem which says that so it becomes perpendicular bisector actually. And this perpendicular bisector also acts at angular bisector of the center subtended by this arc on the center. So there are 2-3 correlations. So now things are same. The theorem number 7 is telling me that if there is slight change in theorem number 7, which is saying that if it is equal. So theorem 7 is saying that if this and this is equal, if a chord bisects the if a line drawn from center of the circle on the chord bisects the chord, then it will be perpendicular. Now how do you prove it? So you know that you can write it, this is A, this is B, this is P, You can write it as OA is equal to OB. You can also write that OP is equal to OP, and you can write that AP is equal to PB, which has been given to you. So this is side congruency. Now you also know that this angle, because angles opposite to equal sides would be equal. So OA is equal to OB. So angles opposite to this side and this side, I mean this angle and this angle would be equal. So angle OPA is equal to angle OPB, and I know that OPA plus angle OPB is equal to 180 degree, and these are equal. So you can say that 2OPA is equal to 180 degree, or angle OPA is equal to 90 degree. As simple as that. So that is how you have to do it. Now let me move to another theorem. So these two theorems have proved that if perpendicular drawn from the center of the circle to the chord, it will be a bisector, and if a line drawn from center of the circle to the chord bisects it, then it will be perpendicular. So these two theorems I have solved it simultaneously. Now there is a corollary to it. Can you please look at it? Go to your book. There is a corollary to it. Just look at it. The corollary says that the perpendicular bisector of the two chords of a circle intersect at the center. Just have a look at it. All of you, if you're all of you have a look at it. Are you doing that corollary? Any doubt in that?
Yes.
Yeah. 11, let me tell you exactly. Our 11th is 11th of April. 28th to 13th of May it will be holiday.
Have you done it? Should I move ahead? Okay, if you are not saying anything, anyway, I have to move ahead. Theorem 8. Theorem 8 says me that equal chords of a circle are equidistant from each other.
It's like a picnic thing. You know, people think that it will be on the resume, on the NASA. But if they're on your merit, then it is a point of interest. If you're paying metric like let me tell you, it will just be
So,
like it's a holiday thing.
A, B, C, D.
You think that we should go on a holiday for 10 days.
Again, I am drawing this.
But don't think that you could add a lot of.
Fine. Now, what I need to do is that if I want to find out distance of this chord from the center, distance is decided by perpendicular drawn from a point to the chord. So I'm drawing a perpendicular from here, and suppose this is M, this is N. I have to prove that OM is equal to ON. How I do it is that I will prove that
The thing is that, yeah,
I take
it will be
triangle
good exposure when it comes to
AMO and triangle
I don't think class 11 or 20 can get into the
C and O.
designing of drawing.
So I know that OA is equal to OC because they are radius. I also know that if a perpendicular is drawn from the center to the chord, it bisects it. So I know that AM is equal to CN because AB is equal to CD. So half of AB will be equal to half of CD, and half of AB is AM, half of CD is CN. So I'm writing here AM is equal to CN, and I know that angle M is equal to angle N. So I have RHS congruency. By RHS congruency, I know that this angle is equal to this angle. So angle A is equal to angle C, and side opposite to it, which is ON, is also equal to ON. So that's how you have to prove it. I hope you understood it.
13th May. You're going where? What are you doing? Where are you going?
This job.
For?
Fine.
Are you having breakfast?
Yeah.
And 28th of April to 13th of May is okay.
Okay. Now let me go to Theorem 9. Theorem 9 says me that The chords of a circle. You solve this. I'm writing it.
Yes.
The chords of a circle.
That is what it should be. The test, what is the outcome, how much student is motivated, that the single-minded focus is there towards the answer or not. Yes.
The chords of a circle.
And it's a dynamic group where we also
Which
ask
are
people to leave the group if they are not up to the mark. If they are just in the group for the passive thing, just for a matter of pride. if they are-
Equidistant.
So many times
From center.
Yeah. Ma'am, they do. Ma'am, they do. What? I keep on receiving calls from the parents that, okay, please consider it for grade 1 batch and we'll work hard and all. But until it comes from within from the student himself, it becomes very difficult to drive. Because some of the parents, some of the students will come initially, but when they see the kind of rigor that is involved, they just don't survive. I mean, it will be based on the performance of the student till the time where they select for that batch. And then every month, if suppose a student was not able to fill authors and suddenly picked up the month of September, then we will replace one student with that new one. So it's a dynamic process.
Just solve this.
Yeah, every month there will be something. Otherwise, ma'am, if I just that is hard to say because many of the current now it will be hard to say because right now we have class 10 who will be running us in January, right? So we have not approached them for admissions. And yes, RNR. That kid will come in RNR, right?
Done. 2 people have done it. I want all of you to write whether you have done it or not. Just don't sit and enjoy.
Everything. It is across entities, ma'am. And
Have you done? 4 people have written they have done. which are Shraddha, Dhruti, Tana and Ritu. I need answers from Anchita, Varsha, Sanjana, Anirudh. There are only 7 people here. Who left? Okay, so 5 people have answered. Now I'm moving to the other one, Theorem 9. So Theorem 9 we have already done. Theorem 10 we will do now. There are too many theorems. Some 18 theorems are there. I want to touch upon each one of them because many a times direct theorems are told to be proved in the examination. Theorem 10 is a bit theoretical, not so theorem 10 tells me that there is one and only one circle passing through three given non-collinear points. Just try to prove it once. Take 2 to 3 minutes and try to prove it. If you are not able to do so, I'll prove it. So let me give you 3 minutes for this. It's 11:30. At 11:33, I'll start solving. You can take help of your book also, though it is not too easy to understand it. Okay, Dhruti, I'll solve, don't worry. So to solve this particular theorem, you need to realize one thing, and that I'll discuss now. It is this. Please understand it. So what I'm trying to say, just look at here properly. Suppose these are the 2 points AB and CD, and I'm drawing a perpendicular bisector like this. Now any point I'm writing here, you should also write any point on the perpendicular bisector of a line is equidistant from the two ends. So you take any point O, this OA will be equal to OB. Why? Because let's take this P, this is perpendicular bisector, so it means that AP is equal to PB and OP is equal, so you can say that OP square plus AP square, which is also equal to OP square plus BP square, because AP and BP are equal, and that would be equal to, here it will be equal to OA square, here it will be equal to OB square, so it means that OA is equal to OB. Now this point O can be anywhere, this length would be same and this is already same, hence this hypotenuse will always be same. So you should also always know that any point on the perpendicular bisector of a line is equidistant from the two ends of that line. Okay, now what we do is, in this particular case, we will take 3 points. Suppose suppose this is point A, this is point B, and this is point C. So this is A, B, and C. Draw this. This is construction which I am doing. You should do it with your compass and all those things. So I'm drawing AB. I'm joining AB. Join AB and BC. Now you draw a perpendicular bisector of AB. So perpendicular bisector of AB would be something like this, and you draw perpendicular bisector of BC. So perpendicular bisectors of AB and BC will intersect at point O. So what I'm doing is I'm drawing perpendicular bisector. Suppose this is PQ and this is RS, and perpendicular PQ is perpendicular bisector of AB and RS is perpendicular bisector of BC. So O is intersection of intersection point of PQ and RS. Now what happens if I draw these lines? So I can say that OA is equal to OB, because any point on perpendicular bisector would be equidistant from the ends of that line, and similarly OB is equal to OC. So OA is equal to OB is equal to OC. Now what I say is that let's make this as a radius of the circle and mark, take O as center and draw a circle like this which passes through these 3 points. So ABC, you will be able to show that with ABC there is only one circle. Now if you try to take any center O dash, this O dash would be coinciding with this O, because to make radius equal from these 3 points, O dash has to coincide with O. So you'll have to write that COR would be congruent with CO dash S. So that's how you prove it. There is nothing else in it. Did you all understand it? Okay, so next theorem we will prove now. Did you? Did you understand this? Okay, so now look at here. Okay, so next one is Theorem 11 is, let me finish off the theorems quickly so that I can move to questions. Of any 2 chords of a circle, show that the one which is larger is nearer to the center. So this is AB, and suppose this is CD, and this is O. So suppose this is OE and this is OF. You have to show that OF is greater than OE. Solve it for 2 minutes, then I will solve it. मैसेज डाल देते हैं सर, एक मैसेज डाल देते हैं सर, क्या रिगार्डिंग अटेंडेंस
जस्ट टेस्ट अपनी फजीयत कराओगे, इंडिविजुअली पकड़ो, ग्रुप में डालोगे ना तो रहेगा कि कोई नहीं आया, हम भी नहीं आए, हम झुंड में इंडिविजुअली पकड़ोगे तो हमको कॉन्शियस होंगे, वो आना पड़ेगा। कॉल लगा दो, पेरेंट और लेकिन ये पहली बार हुआ ना ऐसा, कुछ होगा इनके स्कूल में यूट्यूब नहीं है, नहीं आज वो है ना पोंगल है कुछ।
Formalism 15th.
सेलिब्रेशन हो रहा है शायद डेफोडिल में तो आज हो रहा है सर और आज सैटरडे है
कौन गया है डेफोडिल?
अंकुर है अंकित है और एक और कोई बनता है आगे पहले तो मई था फिर मेरे को केमिस्ट्री क्लास देनी पड़ गई
सुष्मिता है
सुष्मिता नहीं है अभी
वहाँ पे डेफोडिल
अभी नहीं है
वो मुझे बोल के गई कि मैं डेफोडिल जा रही हूँ
कब अभी
सुबह से 10 बजे
कौन गई होगी
पहुंच गई होगी done. Okay, Tane is done. Okay, I'll solve it. Few people are saying me to solve. So what I know is AB is given is AB is greater than CD. So AE would be half of AB and CF would be half of CD. Now OA is equal to OC. So let me take these two triangles. I am taking triangle OEA and I am taking triangle OFC. So let's apply Pythagoras theorem in it. So by the Pythagoras theorem, OA square is equal to OE square plus, sorry, 1 second, not plus. Let me write the Pythagoras theorem correctly. And then here OE square plus AE square is equal to OA square. And on the other side in OFC, OF square plus FC square is equal to OC square. Now I know that from here, I know that these two, I know that if AB is greater than AB is greater than CD, then AE would be greater than CF. So what I can do is that from here I can write, because OA square is equal to OC square, OE square plus AE square is equal to OF square plus CF square. Now if I replace CF with AE, so what am I doing? If CF is replaced by AE, so CF is lesser than AE. So if I put a bigger number here, then I'll have to put a greater sign here. So OE square plus AE square here would be lesser than OF square plus AE square. Why I am putting this greater sign over here is, I am not putting this equal to sign. I am putting this greater sign because I am replacing CF with AE, and AE is a bigger number. So this AE and AE gone. So OF square is greater than OE square, or OF is greater than OE. This is how you have to prove it. So just write it down. and I will move to theorem 12. This for class 9. Revised complete circles.
Yes.
Fine, you can go through it if you want.
Yes.
Fine. Okay.
Which batch is this?
R&R. Let me move to theorem 12. Theorem 12 tells me that if any of two chords of a circle show that the one which is nearer to the center is longer, is exactly the opposite of the theorem. You just have to prove it the same way. I hope all of you will prove it in next 2 minutes. It's 11:49 in my watch. Just solve it in 2 minutes and write your comments. Done. Okay, 3 people have already done it. From next class onwards, I'm taking it on Google Hangout because it's good for me to hear all of you.
we will use it. Like that kind of.
Somebody might have kept it somewhere, or Melissa might have taken it. Just asking.
I'll just ask our patient members.
Okay, 5 people of you have already done it, so I'm not solving it. If anyone wants me to solve it, please write it down. I'll solve it for you. Please write it down. I'll solve it for you. Otherwise, I'm moving to another theorem. I have to solve 1, 2, to solve 4, 5 more theorems. Okay, as nobody is responding, I'm moving to another theorem. Now I'm moving to congruent circles. So theorem 13 is, if two arcs of a congruent circle are congruent, then the corresponding chords are equal. If two arcs of congruent circles are congruent, then the corresponding chords are equal. So how do you prove it? I will prove it for you, don't worry about it. So I'm taking two circles which are congruent. So this is O. And this is O dash. This is AB. This is CD. So I know that this circle is two congruent circles, so I'm writing circles. Circles are congruent when their radiuses are equal, so I'm writing OR, and this is another circle. So give me a moment. And I have another circle which is O dash R, and they are congruent to each other. Now I know that AB, it has been given to me that chord AB is congruent to chord CD. So what I can do is that, first case, AB and CD are minor circles, minor arcs, sorry. If they are minor arcs, so let me take triangle OAB and triangle O dash CD. So OA is equal to O dash C, OB is equal to O dash D. They both are radius, and I know that angle AOB is equal to angle CO dash, because if the chords are congruent, chords becomes congruent only when they form same angle on the center. So by this I can prove that this is SAS congruency between the two of them, and hence AB would be equal to CD. Similarly, for the major arc, you can take it on the other side, and you can do so. So in that case also, what happens here is, here arc AB is equal to arc CD. For major arc, you can write as arc BA opposite from here to here. Arc BA is congruent to arc arc DC. So from here to here, and everything remains same, and you can prove it the same way. So that's how you have to prove this. Next theorem that you have to prove is theorem 14 is, if two chords are congruent of congruent circles are equal, then corresponding arcs are congruent. And when I say arc, I talk about all three arcs: major, minor, and semicircular. Just solve it. Okay, Dhruti has done it. Okay, Sanjana, I'll solve it. Let's give others 2 more minutes.
So the increase in volume of the element at 90. Okay, before that, what do I know? I know that my phase was very much more S naught, and then sine, then omega E minus Y. This was not is S. What are you? ये जो S bracket में है, एक सरफेस का इसकी वैल्यू को बताया वो कैसे बताया कि how and how what is change in volume? Change in volume is A delta S. Change in volume. Change in volume. So, change in volume A delta is equal to parent half A into delta S. A into delta S is initial volume. Then मैंने इस सरफेस को S से पुश किया. ये सरफेस भी S से पुश हुआ तो नेट कैंसिल आउट here, but एक इसका एलिमेंट रहेगा. When change in volume A delta here.
Okay, so let me solve that. Few people have already solved it, and few people are asking for it. So I'm solving it. If I'm talking about 2 congruent circles, I make 2 congruent circles. This is my C O R, and this is my C O dash R. And what I need to do is that first I'll assume for minor arc. So what I'm doing is I'm taking minor arc AB here, and I'm taking minor arc CD here. So I draw a line like this, and then I make a corresponding chord, and I draw this, and I make a corresponding chord here. Now I know that OA is equal to O dash C, and OB is equal to O dash D, and AB is equal to CD, which has been given to me. It means that it is SAS congruency. If it is SAS congruency, then angle AOB is equal to angle CO dash D. It means that both the chords, and if chords are making corresponding angles, this is by CPCT, you can write here. So it means that measure of chord AB is equal to measure of chord CD, or AB is congruent to CD. As simple as that. Now, if I have to do it for minor arc, sorry, major arc, it would be exactly the same thing, just that you have to select the arc differently. Case 2, I am taking that it is for major arc. So for major arc, what I will do is I'll take A, B, and CD, or BA or CD. So AB also can be major arc, and in that case BA becomes minor arc. So it's actually the same thing. So you can write that AB is equal to CD, and you can say that when this is theta, because I have already proved in case of minor arc that this and this are equal. So if I take it for BA and DC, so you can say that this will be 360 minus theta, and this will be 360 minus theta. Hence, angles made by measure of angle made by BA is equal to measure of angle made by DC. And if they are equal, hence arc BA would be equal to arc DC, as simple as that. So this is for major arc. And for semicircle, you can directly say that it makes 180-degree in both the cases, hence they would be equal because the diameters are equal. So this is how you had to prove it. Now let me move to theorem 15. And what I want you, because I have proved most of the theorems in the other part. It's just that now I'm using two things. So what you need to do is that theorem 15 to theorem 18 in your book, you go through it and just let me know if you are not getting any theorem, and I'll start solving questions. 1 hour I'll take questions from now. So I give you 3-4 minutes to solve it. Please do it. Just do it.
mass of the medium multiplied by wave number of the wave. Wave number is omega by e. Omega is 2 by x. Depending on my frequency divided by the velocity of the wave. So how is special activity? Factor of e find the amplitude of vibration of one. E is fine.
Have you done it? Okay, I've got done message from 3-4 of you. So should I go to the questions now? I'm done with theorems of this section. Okay, so now let me start with the questions. So first question is, and I'm not doing easier questions. So this is the first question. This is CD, this is a chord, and this is AB, this is a chord, and this is EQ, and this is center O. So I'm saying that R is equal to 5 centimeter, AB is equal to 8 centimeter, and CD is equal to 6 centimeters. OP parallel to AB, sorry, perpendicular to AB, and OQ perpendicular to CD. Determine the length PQ. I've written it, Shraddha, on the board. Okay, for this question, try to understand this is 90 degree, this is 90 degree. So OP square is equal to OA square minus AP square. OA is 5, so this is 5 square, and AP will be half of AB. So minus 4 square. So 5 square minus 4 square is nothing but 3 square. So OP comes out to be 3. Similarly, OQ square is equal to OC square minus CQ square. So this is 5 square and this is CD is 3. So CQ will be 3. So 5 square minus 3 square. So this will be 4 square. So OQ will be equal to 4. So PQ is equal to OP plus OQ, and that is 3 plus 4, that comes out to be 7. So this is how you can solve this question. Now next question. Okay. The next question is, I'm writing here two chords AB and AC of a circle are equal. Prove that. And I have told you this. I have told you that how to prove this. While proving, prove that the center of the circle lies on the angular bisector of angle BSC. Just solve it.
And we have this variable. One machine of AC square by 4. So AC square by 4 is R square. A3 R square and 3 R square. So we take one machine. We got everything. Minus 3 square is minus 4. I just, there's something wrong with the rest I got. So I got 3 square. Yeah, but I missed it. 3 hours. So minus 1.
Okay, so I will solve this question. Just look at here. Okay, so suppose I have two chords AB and AC. So A is the common point of the two chords. So this is B and this is C, AB and EC. And the circle is COR. So this is my point O. And I am drawing a line from here through O. So suppose this point is D and this is O. And this is my chord BC. Now O lies on line AD. So I have to prove that AD is bisector of angle BSC. So I know that AB is equal to AC. And suppose this point is M. So what happens is, let me take triangle BAM and triangle CAM. So in this particular triangle, AB is equal to AC and this angle is equal to this angle. It has been already given to us. So BAM is equal to angle CAM and AM is common among both. So this is SAS congruency. So you can say that from here BM is equal to CM and angle BMA is equal to angle CMA, and addition of both these angles BMA plus angle CMA is equal to 180 degrees. So these two would be equal to 90 degrees. So it means that AM is perpendicular bisector of of BC chord. So if AM is perpendicular bisector of BC chord, so AD would also be perpendicular bisector because AM is a part of it. Now what can be done is that in this, what I assumed initially that O lies on AD. So you can solve it from the other side also. You can say that these two angles are equal, and if these two angles are equal, you will have to prove that this line O lines on AD. So as soon as you prove that AD is a particular bisector, you know that AD passes through O, and the theorem gets proved. So that's how you can do it. Did you guys understand it, or do I need to solve once more? Did you guys understand it? Try to understand. I'll again say that the center of the circle lies on angular bisector of BSC. As soon as it has been told that this is angular bisector of BSC, this has been given to me. AB is equal to AC has been given to me because here only it has been written, and AM is common. So this SAS congruency is proved. If SAS congruency is proved, I can say that this and this is equal, and this angle is 90 degree. It means that this line AM, which is a part of AD, is perpendicular bisector of the chord. Perpendicular bisector of the chord will always pass through the center. That's what you have to prove, and this is what you have to prove. So let me go to the next question. The next question which I am giving is, I'm writing the next question. If two circles intersects in 2 points, prove that the line through there centers is perpendicular bisector of the common chord. You solve it. Done.
P plus C is equal to A plus C plus B. So P is equal to A plus
Okay. Sanjana has done it. Okay, Dhruti, take your time, no hurry.
I will divide the entire equation by what is it? E times gamma times E को मैं लिख सकता हूँ डेल्टा V plus डेल्टा P.
So A plus B plus 2C is 1. So A plus AB plus OB plus C plus
E times gamma
A equal plus
E times gamma
B minus Y is equal to
upon E upon delta
ABC is equal to B minus A minus B.
E gamma
ABC A plus B AB so S is equal to A
Anchita, in the previous question, you are not supposed to prove that AD bisects angle BC. You are supposed to prove that AC passes through the center. The perpendicular bisector of angle BAC passes through center. It was already given that, sorry, angular bisector of angle BAC passes through center. So it has already been given that it is angle bisector, and that is why I assume that BAM is equal to angle BAM is equal to angle CAM. And as soon as I took that, I was able to prove that the two triangles are SAS congruent. Hence, I was able to prove that AD is perpendicular bisector on the chord. If AD is perpendicular bisector on the chord, any perpendicular bisector on any chord will pass through center. That is what the observation was. When I finish the session, you can go to that question and you can find it out. What about this question? Anyone wants me to solve this question? Okay, let me solve this question for you. So I'll take a bigger circle like this, and I'll first let me draw this line. And then let me take a smaller circle. Done? Yeah, done. Hide. So this is O, this is O dash, and this is the common chord. Common chord I am assuming to be AB, and this point I am assuming to be M. Let me draw a line from here to here. This is the radius R, this is the radius R, and let me draw these 2 points also. This is the radius S and this is the radius S. I have to prove that OO dash is perpendicular to line AB. So construction I have already done. I am taking triangle OAO dash on the upper side, and I am taking OBO dash on the lower side. So OA is equal to OB because they are radius. O dash A is equal to O dash B because they are radius, and OO dash is equal to OO dash. Hence, OA O dash is congruent to triangle OBO dash. If this is congruent, then what is possible? Then I will prove that angle AOO dash is equal to angle BOO dash. This and this, because they are opposite to equal sides, and angle AOM, because this is part of it, because it's the same thing. Rather than O dash, you can write it AOM, and angle BOM are equal. if angle AOM, these two angles are equal, rather than O dash, I am taking another point on the same line. So M is, see, OM is part of OO dash. So this O dash can be replaced with M. So now let's take triangle AOM and triangle, which triangle I should take? BOM. So if I am taking this, I know that OA is equal to OB. I also know that I have just proved here that AOM is equal to angle BOM, and I know that OM is equal to OM.
We follow Cbse.
So OM is equal to OM. So these two triangles AOM is congruent to triangle BOM. And if this is true, then what happens is AM becomes equal to BM and angle OMA becomes equal to angle OMB. And I'm writing here angle OMA plus angle OMB is equal to 180 degree, and the two are equal. Hence, angle OMA would be equal to angle OMB, that is equal to 90 degree. So as soon as you prove this, the line O dash become perpendicular to AB because M is part of line O dash. This is how you have to solve it. Let me take another question. Question is, prove that the perpendicular bisector of the chord of the circle, the perpendicular bisector of the chord of the circle always passes through center. Just do it. Dhruti, I'll take one or two more questions and then I'll finish off. Maybe maximum by 1:15. Hey, what are you doing?
So,
Oh, great. Which book is this?
I don't know.
You both of you buy cars and books.
How are you guys? Okay, example. Yes. So, now thank you. How are you? How is it going?
No, it's fine.
Your technical chemistry doubts or things? Anything else you want? I can also take it. So,
We finished. What about the
हाँ बोलो क्या है और परेशानी
Hey, my class time also.
You know, with time for waste.
I'm putting it. You have to buy it. You can't, even if you do one page, you are one page ahead of your competition. So already people are buying it from your classroom. You also have to do it. People won't say it in front of you, but they do it.
Great. Great.
Okay, have you done this question? Tana has done it. Great.
Great.
Okay, Varsha's done it. Dhruti has done it and Sanjana has done it. I told Varsha it's still 115 maximum. I'm doing it because I need to finish it fast. I'll take one or two more extra classes. So maybe next week I'll have one class at center and one class on Sunday. Next Sunday I'll have an extra class for you guys. And that class also would be for 3 hours. Okay. So as most of you have done it, anyone who wants me to do it, otherwise I'll move to next question. Okay, so no one is saying me anything. I'm moving to next question. The next question is that I want you to solve is this. So this is a circle which has been made, and there is a chord AB. There is another chord CD. So, and they cut at E. So angle. So I'm writing here equal chords AB and CD cut at right angles at E. Now this is the center O, and I draw a perpendicular here OM, and I draw a perpendicular here ON. If OM and ON are midpoints of, so as soon as I say midpoints, you should understand that midpoints of AB and CD, which I'm indirectly, though it has not been, this is OM, which indirectly, which has not been written in the question, OM would be perpendicular to AB and ON would be perpendicular to CD. That you have to assume, because so prove that OMEN is a square. So this is the last question. After that, I will wrap.
Just last question. Can go, right?
This minus is by 2 divided this minus.
Oh, अच्छा अच्छा तो कितना
This minus
कितना
A
बहुत क्लियर है
You should know that this angle E is 90 degree. So this question,
वो भी है अभी सेंटर पे वो याद किया
So x minus y is 360. This 360 minus 360. From
okay, Dhruti, anyway, this is the last question. You can leave or you can wait for 2 minutes. Anyway, I'll finish it off in 2 minutes. Now try to understand. You join this OE. Dhruti, just wait for this question. I'm just finishing it. So OM is perpendicular to AB because they are midpoint. M is the midpoint, and ON is perpendicular to CD. So in this particular triangle, let me take triangle OME and triangle ONE. OM is equal to ON because perpendicular drawn to the equal chords would be equal, and angle M is equal to angle N, which is equal to 90 degree, and OE is equal to OE. It means that I have RHS congruency. If I have RHS congruency, then ME would be equal to NE. I have already proved it. And OM is equal to ON. So sides has already been proved as equal. Now if I prove that all the angles are 90 degrees, so I know that angle M and angle N are 90 degree. Angle E has already been given to me as 90 degree. So angle O has to be 90 degree because in a quadrilateral the total angle is 360 degree. So all angles are 90 degree and all sides are equal. Hence OMEN is a square. That is how you have to prove it. So okay, what I'll do is which chapter is this? Can you write me the chapter name in your chapter number in your book? Please just write the chapter number in the book. Okay, so circle exercise 12A is your homework. Exercise 12A is your homework. Just finish it off. Okay, so thank you so much for joining the class. Let's meet next week and finish up the circles.